here is another problem. This is simple oscillation problem. It says in the system shown in the figure, the masses of the loads are these small blocks, nothing else. Masses of the loads are equal to m. The spring constant is k. There is a spring, you can see here. The spring and the threads are weightless. Thank you very much. And there is no friction. Thanks again. At the initial moment, the loads are motionless, that means are at rest, and the system is in equilibrium. Rest and equilibrium both. That's great. Then holding the left load, you just hold them. Move the right one down by a distance a, right? After which they are released without the initial velocity. Find the maximum velocity of the left load during the oscillations. Assume that the threads remain taut all the time and the loads do not hit the other bodies of the system. Okay, fine. So one load is being held, and at the same time other was brought down, and the spring and the string all are weightless. So equal forces are being exchanged between loads from gravity or from the string or a spring, whatever it is. And their masses are, since their masses are equal, so this equality of masses, you can think about the oscillations that occur after the loads are released. And I can see just one thing: the center of the spring remains motionless. Therefore, this problem is equivalent to the problem of finding the maximum speed of a load of mass m hanging on a spring with a spring constant of 2k. Because I can see again a split in the spring, because its center is going to remain at rest, and the spring has been divided into two springs. A spring of a spring constant k has been split into two springs, so their spring constants will become 2k. And after its initial downward displacement, both of the blocks, you can see, or you can think about the right load, and you can say that after its initial downward displacement by a distance of a by 2, simply a by 2, it has traveled the distance a by 2 only, and next a by 2 was awarded to this left block, though it was kept held and it was being moved by a length 2a, but the problem is equivalent to some other situation when the middle of the spring was at rest and it was given a displacement a by 2 and it was given a displacement a by 2. And so I can say here omega of their oscillations will be simply 2k by m, the circular frequency or angular frequency of oscillation, and their amplitudes are equal to a by 2, and therefore maximum velocity you would like to a omega, and that is a by 2 under root 2k by m a omega, and this will become a under root k by 2m, and that's our answer. Thank you for watching.